Hi friends, welcome back to our YouTube channel. Today we have to discuss about differences between RISC and CISC processors. It is one of the most important concept in computer organization, computer architecture, overall computer organization and architecture. It is the most commonly asked question in the examination point of view. So please observe carefully. Before going to this video, in the previous video, I already discussed about what is a RISC architecture and its block diagram and what are the characteristics of RISC architecture and what is CISC architecture and what are the characteristics of CISC architecture with the block diagram. If anybody wants, please refer that two videos in my YouTube channel, DIVVELA SRINIVASA. Go to the playlist Computer Organization. We already know that based on the architecture supported, computers are divided into two types. First one is a RISC computer, second one is CISC computer. RISC stands for Reduced Instruction Set Computer. CISC stands for Complex Instruction Set Computer. Okay, so that is the abbreviation is the first point. Next one. Second point is RISC processor supports only few number of instructions, that is approximately less than 50. Whereas in the case of CISC processor, it supports large number of instructions, typically from 100 to 250 instructions. Next point is RISC processor supports only few addressing modes, whereas in the case of CISC processor, it supports large number of addressing modes, so typically from 5 to 20 addressing modes. Next one is RISC processor can take only one instruction cycle to execute simple instructions. That means, so there are some simple instructions are there in a particular program. To execute that simple instructions, RISC processor can take only one cycle. Whereas in the case of CISC processor, it can take more than one cycle or two or more cycles to execute complex instructions. So typically it can take 2 to 15 clock cycles to execute complex instruction. In the case of RISC processor, an average CPI means clock cycles per instruction. To execute one instruction, it can take how many number of clock cycles? On an average less than 1.5. But whereas in the case of CISC processor, an average CPI is in between 2 and 15. To execute one instruction, it can take 2 to 15 clock cycles. Okay, if it is a complex instruction. Next one is in the case of RISC processor, only very few instructions can refer the memory. Okay, to execute instructions, only few instructions refer the memory. Okay, but whereas in the case of CISC processor, most of the instructions can refer the memory. Next one is RISC processor supports fixed length instruction format. Okay, so whatever the instructions that are executed by the RISC processor, that instructions have fixed length instruction format. All the instructions can contain same length. But whereas in the case of CISC processor, whatever the instructions, that are executed by the CISC processor can take variable length. Okay, that means one instruction to another instruction, the length of the instruction varies. It may be 16 bits, 32 bits and 64 bits. But in the case of fixed RISC processor, it uses only 32-bit instruction format. Next one, instructions are executed by the hardware in the case of RISC processor, because in the RISC processor it contains only hardwired control unit. By using that hardwired control unit, it can execute instructions, whereas in the case of CISC processor, instructions are executed by the microprogram. Okay, because it uses microprogrammed control unit. By using that microprogrammed control unit, it can execute instructions through microprogram. Next one, RISC processor contains only hardwired control unit instead of microprogrammed control unit, whereas CISC processor uses only microprogrammed control unit instead of hardwired control unit. Next one is, in the case of RISC processor, complexity is there in the compiler only, but whereas in the case of CISC processor, complexity is there in the microprogram. Okay. Now we can go for next point. Next point is, RISC processor supports highly pipelined. So that means pipelining concept can be done in the RISC processor highly, whereas in the case of CISC processor, pipelining concept may not be used. Suppose if it is used, pipelining can be done within a less manner. That means less pipeline or not pipelined, whereas in the case of RISC processor, highly pipelined. So that means pipelining concept means instructions are executed in the pipelined fashion, so that execution time is very less. It can take less number of cycles to execute all the instructions. So RISC processor supports highly pipeline, whereas in the case of CISC processor, less pipeline or not pipelined. Next one is, RISC processor contains multiple number of registers within the CPU. So hence we can say that RISC processor contains multiple register set, whereas in the case of CISC processor, single register set is available. So because most of the operations can be done in the memory, so that it contains only single register set. Next one, memory access limited to load and store instructions. In the case of RISC processor, most of the instructions are most of the operations are done through the registers within the CPU, so that memory accessing is very limited to two instructions, that is load and store instructions. So for load and store instructions uses the memory only, so that memory access time is limited to load and store instructions. But in the case of CISC processor, most of the instructions can refer the memory to manipulate the operands within the memory. Only less number of operations can be done through the registers, so that it contains only single register set. Next one, all operations are done within the registers, so that it contains relatively more number of registers within the CPU, but most of the operation can be done within the memory, but less number of operations can be done through the registers, so that it contains less number of registers. Next one, execution time. Execution time is very less in RISC processor, whereas in the case of CISC processor, execution time is more because of control memory. Because of control memory, it can take more execution time in the case of CISC processor, but in the RISC processor, execution time is very less. Next one, instruction size is one word. A RISC processor supports the instructions. The size of the instructions is one word, that is 32 bits. But in the case of CISC processor, so some instruction size is greater than one word. So approximately double the word. So 64-bit instructions are also executed by using CISC processor. At that time, instruction size is double the word, greater than the word. Okay. Next one, less number of data types that are supported by the RISC processor, but CISC processor supports more number of data types because it supports more number of instructions and more number of addressing modes. But RISC processor supports only less number of instructions and less number of addressing modes, so that less number of data types that are supported by the RISC processor, but CISC processor supports more number of data types because it contains more number of instructions, that is 100 to 250 instructions, and more number of addressing modes, 5 to 20 different addressing modes that are supported. Next one, examples for RISC processor is Intel i860, Spark, MIPS R3000, IBM RS by 6000. So these are the examples for RISC processor. Whereas the examples for CISC processor is IBM 370 computer, VAX computer, Intel 8X86. So these are the examples for CISC processor. Next one, this is the RISC architecture and this is the CISC architecture. So here hardwired control unit we are using in the case of RISC processor. Here microprogrammed control unit we are using in CISC processor. So here instruction cache and data cache both are different. So here in the main memory we are storing the programs and data. So the main memory can be divided into two parts. One is the instruction part and second one is the data part. In the instruction part we are storing the instructions. In the data part we are storing the data. Instructions are passed through the hardwired control unit. So through this path, and data is passed to the hardwired control unit by using this path. More frequently used instructions are stored in the instruction cache. Frequently used data is stored in the data cache. So whenever repeatedly executed some instructions, so instead of taking from the main memory every time, they can be taken from instruction cache and data cache. Okay, so this is the architecture of hardwired control unit. So in the case of CISC processor, so instruction path and data path are combined, and instruction cache and data cache can be combined as single cache. Here in the main memory we are storing both programs and data, so that can be sent to the microprogrammed control unit by using this path. Next one, in the control memory we are storing the control information that are the control information in the form of binary control signals. That binary control signals are generated by the microprogrammed control unit. that information is stored in the control memory. So because of this control memory, so the execution time is very less. Okay, so this is the architecture of CISC and this is the architecture of RISC. So these are the 18 differences between RISC and CISC processor. So thank you one and all for watching this video. If you like this video, please click on the like button and click on the bell button to get the future updates in my YouTube channel. If you like this video, please subscribe my YouTube channel DIVVELA SRINIVASA. Please forward this channel to your friends and classmates. It is very useful. So thank you one and all for watching this video.